For this question, you need to write the following complex number in polar form, and then hence find the value of 1 plus root 3a to the power of 9. Okay, so the first thing we need to do is write it in polar form. In order to be able to do that, we need to plot it in an Argand diagram to see roughly where it is. So this is the real axis, this is the imaginary axis. So then 1 is here, root 3a is up here. So you can plot the point 1 plus root 3a, here it is. Now what we're trying to do when we find the modulus is to find the distance from this point to the origin. In order to do that, it's going to be the square root of a squared plus b squared. So you fill the values into the formula, put brackets around every number, especially if it's going to be a negative number. Put it in the calculator and you'll get your answer. So the modulus is 2. The next one we need to find is the argument. We're looking for the angle from the positive real axis right around to this point. So in order to be able to do that, we're going to make a triangle. It's going to be a right angle triangle, clearly. So then this distance is root 3, this distance is 1, and then we're going to use the tan of the angle is equal to the opposite over the adjacent. So that means the tan of the angle is equal to root 3 over 1. So to get the angle, it's going to be the tan inverse of root 3 over 1, which is equal to 60 degrees. To write this in polar form, it's going to be in the form r cos q plus a sin q, and we fill our values into the formula. So it's going to be equal to 2 cos 60 plus a sin of 60. Now that is it written in polar form. Then we need to use De Morvis theorem to try to write it to the power of 9. Now De Morvis theorem states that if we're looking for a complex number to the power, we need to put the complex number to the power here, then we go cos 9 by 60 plus a sin 9 by 60. And what we can actually do then is we can put each individual part into the calculator and we'll be able to simplify our answer. So we work each part out individually. We can keep this as 2 to the power of 9 for now. Cos of 9 by 60 is minus 1, and then the sine of 90 is just 0. So you'll see that 0 is end up going to cancel. So then we're going to multiply the brackets, so 2 to the power of 9, it's going to be minus 2 to the power of 9 is our answer, because then this by 0 is just 0. Or if you prefer, you can write it as minus 512, which would be our answer there.